Hey guys, today we're going to talk about projectile motion, and projectile motion is an application of quadratic equations in real life. So we're going to look at ways that they can be used to solve real world problems. So the first problem we have, and I'm just going to show you various aspects of one problem, and this detailed problem should help you answer all of the less detailed problems that you have on the rest of the worksheet. Okay. A soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h of t equals negative 16t squared plus 90t gives the height h of the ball after t seconds. So first, let's just draw this. So a soccer ball is kicked from the ground. So we have the ground here, and there's our soccer ball. It is kicked up in the air, and then it will come down and land somewhere over here. All right, so when we think about this in terms of an equation, the ground is our x-axis. And our x-axis in this problem represents the time that the ball has been going. So it's the x-axis, but it's going to represent t for us. And our y-axis represents height, which is h. Okay, so at 0 seconds, the ball is at 0 height because it's still on the ground. And then as time goes on, the height goes up and then back down. Okay? So there are a few things that we could grasp from this. We could see how high does the ball get. We could see how long until the ball is back on the ground. There's lots of things we can look at. So we're going to use this drawing to work through a few of our problems. The first question that it asks us about this situation is how many seconds will it take for the ball to reach its maximum height? So let's just look at our picture and remember that this is a soccer ball going up in the air and coming back down. So its maximum height is somewhere in this vicinity, like it's right up here. And if we were to use this point, the y-axis tells us height. So that would tell us how high the ball went, but this wants to know how many seconds it takes to get there. So that means we need to find the x value, or the value of t, at this point. Now, if this were a parabola, and we wanted a line that went through the vertex and divided it in half, then what line is that? We know that to be the axis of symmetry. And the axis of symmetry tells us what the x value at the vertex is, and it's negative b divided by 2a. So in this case, we have t equals, b is 90, so we have negative 90 over 2 times a is negative 16. And whenever we reduce this, we are going to get t to equal 2.8125 seconds. And that is your answer for how long it takes the ball to get to its maximum height. The next part asks us, what is the height of the ball? So we know that the x value of this point, or the t, is 2.8125. So in order to find out what y equals here, or what h equals there, then we would use our equation to find the height at 2.8125 seconds. So that's going to be negative 16 times 2.8125 squared plus 90 times 2.8125. And you can just type that straight into your calculator, and you're going to get h of 2.8125 equals 126.5625 feet. And you don't always have to round to 4 decimal points. I want at least 2. Other than that, it's kind of up to you, whatever you like for that number. Doesn't really matter to me right now. So at least 2, you can go up to 4. Okay, so we just found that the ball goes at its max height 126.5625 feet in the air. So if you remember our regular plain old parabolas, we just found the axis of symmetry and we found the y value of the vertex. And so that allows us to know at what time the ball hit its maximum height and what height that was. So I've kept the chart of what we know so far. I cleaned it up a little bit. And the next part is give the domain and range of the function. So domain asks us about what x values are included in this function. And since we know that this is a real world problem, these lines will not go on forever like they normally would in a parabola. Instead, they start and stop on the x-axis because a soccer ball cannot go below the ground. Or at least this problem doesn't tell us that it can, so we're going to assume that it can't, okay? There's no hole in the ground there or any, weird situations. So from left to right, the domain, the x-axis, we want to know where it starts and where it ends. So the first point, the furthest left on the x-axis is at 0. So we know that 0 is going to be the start of our domain. Then we need to find the furthest right point of our function. So we know 0 is going to be less than t, and then t will be less than or equal to whatever this number is, but we need to find that number. And in order to find the x-intercepts of a quadratic equation, we set it equal to 0 and we solve for x. In this case, we're using t, so we want to know what time the height is 0. So we're going to say that at 0, we have negative 16t squared plus 90t. And you can use whichever method you prefer of solving quadratic functions or quadratic equations. It doesn't matter, whatever one you want, whatever works good for you. I'm going to factor this one because there's no c term. So all I have to do is take out a greatest common factor of negative 2t. And that gives me 8t minus 45 left inside. And then I set each factor equal to 0. So negative 2t equals 0. And that's going to give me t equals 0, which is that's the starting point. We already knew that that was going to be one of our answers. But this one gives us 8t equals 45, and then t equals 45 over 8, which reduces to, because we wouldn't say 45/8 of a second. When you're talking about units like this, unless it's a pretty fraction, you usually want to use your decimal forms and just round those off. And so we're going to get t equals 5.625 seconds. And that is the time that it takes the ground to hit the ball to hit the ground again. And so our domain only goes up to 5.625. So the range is a lot easier. We found domain already. The range is the y values. And so we're talking about the height of the ball. So we want the lowest height it can be at. So the lowest height would be 0 because it can't go below the ground, remember. So it's definitely going to be 0 is less than or equal to h. And then the maximum height that h can be is right here. We already found the highest point. So it's 126.5625. And that is how you find domain and range. So let me know if you have any questions about the other ones, but I genuinely think that the first problem has all of the different types of problems in it. So I think after this, you should be able to kind of work with those and do pretty well. So thank you for listening. Have a great day.